So Benny and I were both from Tesco Retail. And today we're going to be talking about how we support a large organization with its data science needs. We'll be talking about some of the platform approaches that we use. We're going to be doing this, though, at a very high level. We're not going to be going into any technologies quite deliberately. Once we've given a bit of a platform overview, Benny's then going to go into search and recommenders use cases. So, okay, so next slide. So what is Tesco? So I'm sure that many of you will have heard of Tesco, particularly those of you that are based within the UK. So Tesco, we're the UK's largest retail organisation. We operate in a number of other countries. We are very large. We've got approximately 300,000 people that work for us. And we have sales revenues in the region of more than 50 billion pounds. So we're a very large organisation. So if you drop onto the next slide, Benny. So this breadth and scale is really, really interesting from a data science perspective, because behind the very physical presence of our supermarkets, we've also got a very large and growing online retail front. But behind both of these, as you can imagine, there's a ton of stuff that we're having to do, from everything from supply chain, dealing with suppliers, property management. When people are buying stuff and ordering online, we've got all the fulfillment side of things that we've got to deal with, and we're trying to continuously make this more and more efficient. So there's a ton of stuff that we're doing. We're very, very broad, but also everything we're doing is very, very at a very large scale. So we're hitting something like 1 billion API calls per day, and this can go up to 30,000 API calls per second at peak. So everything is done at scale. So what we have within a data science engineering perspective, though, is that we need to be able to build things in such a way that we can empower lots and lots of different use cases and do this in a very, very efficient way. So if you go to the next slide, Benny. So in any individual data science project, teams are going to be focused on a particular business goal. So this might be recommenders, it might be something to do with computer vision, it might be something to do with commodity trading, etc. Many use cases. But as a group, as a community, we all have several common goals. So one is that we want to be able to help data science teams move faster, to be able to build models quicker. So they're going to need the tools and the data to help them in this process. Secondly, once they've actually built a model, we're going to want teams to be able to deploy these models quicker. So we want standard ways of being able to deploy quicker. Then once we've deployed a model, we want to be able to monitor it better, more effectively, but also in a way that's relatively lightweight and not too cumbersome. So in the next few slides, we'll talk about some of the design considerations that we have to make within this process. We'll be talking a bit about infra, some of the components and some of the considerations that we use. And then Benny is going to go into his examples. But before I go on, I'm just going to say I don't have anything today on what the ML lifecycle is. I've made an assumption that this audience here will be familiar with machine learning and that machine learning lifecycle. But what I will say is that any project we start with is always going to start with what's the business problem that we're trying to address. So there's a standard ML lifecycle. It goes from business understanding to data acquisition, modeling, deploying your model, and then assessing that model in the real world and maintaining it. But that's the sort of life cycle we have in ML. But actually, from an engineering standpoint, one of the first things we're going to say is, well, where do we want this solution to be deployed? So if you go on to the next slide, Benny. As with any large organization or most large organizations today, we've got presence in the cloud. So we're working with many of the well-known major cloud vendors. But in addition to this, we have our own private cloud, and this has all sorts of benefits for us in terms of infrastructure and data. In particular, we do a lot of our Spark-based ETL work on our private cloud. In addition to this, though, one of the things that's quite, well, very interesting in an organization like ours is our edge compute. So we have a significant amount of stuff that's going on actually within store, within warehouse, pit tills, PDAs, warehouses, vans, etc. So there's a lot of really, really interesting stuff there. But for the sake of today's talk, and because Benny's going to be talking about search recommenders, everything is in that cloud environment. So if you jump onto the next slide, so that's the where we're doing our compute. Another one that's really, really interesting though is some of the things that we have to consider around volume and velocity. So any machine learning project is likely to have some phases around data engineering and feature engineering, building the model, and then using that model in inference. As mentioned in that last slide, one of the first things we need to think about is understanding that business need. But this is going to then lead to some really, really interesting questions around volume and velocity. So for example, how frequently do we need to rebuild the model? Do we need to rebuild it on a regular basis? What about when we're running the model? Do we run the model, say, once a week, or do we need to run the model much more frequently than that? This is going to lead to some interesting questions, such as, do we need to do stream-based processing, or can we get away with batch, or do we want some sort of combination of both? Alternatively, what are our consumers going to be wanting to run the model on demand, say, for example, for a REST API? We're then thinking, well, is it true big data, or is it a small data problem? Often what we'll find is that we're starting off doing ETL in a big data type setting. So Spark is a key starting point. But actually, when it comes to building models, we've been able to get down to a much more reduced data set size. When it comes to building the models, can we get away with using CPU? Do we need to use GPU? And finally, what sort of computer we're going to be talking about? I've mentioned Spark already, but often, can we use serverless type compute? So there's all these things that we're having to consider when they're doing that early design. But what I'll say is that a lot of this is standard engineering type design work. So there's some stuff that is much more specific to the machine learning world. So if you go to the next slide. So one of the things that's really, really interesting in the world of machine learning at the moment is MLOps. And this is a really, really exciting area at the moment. There's lots of new ideas and tools that are coming about. It's very, very fast moving. I've seen reference to this seminal MLOps paper presented several times already at the conference, which has been really, really good for me. It shows that it's the right place. But really, the general premise behind MLOps is that while you've got your ML code, which is the bit in the orange, when you're running machine learning solutions in a production environment, there's a ton of stuff that sits around that. So if we move on to the next slide. So any sort of machine learning solution is going to look a bit like what you can see here. We're going to be bringing in data. We're going to be transforming it. We're going to be extracting features. The features which the data scientists are going to be looking to identify, they're going to be using these to try and build their models. Once they've got a model that they're happy with, they're going to be promoting it or deploying it. We're then going to be using it to run new predictions. But actually, when we're doing things at scale in a big industrial setting, there's a lot more to it than this sort of simple flow. So I've already mentioned velocity and volume in terms of two V's of the big data world. We've actually often got to deal with another V, and that's the V of variety. So we've got many, many data sources that we potentially are wanting to connect to. So we need to look at stuff around this. This can be everything from data catalogs to connectors, ingress frameworks. As we bring stuff in then, how do we validate? How do we check the quality of that data? And there's other other stuff that we want, such as, do we need to measure data lineage? Do we want to have some sort of data versioning, particularly when you're building your models? Moving into feature engineering, I've already mentioned that we do a lot of stuff in Spark, and the data scientists are going to be working out what sort of features they want. But there's a lot of other stuff here, such as how we're going to monitor those models, for example, for data drift and feature drift. And finally, we're also looking at feature stores. So feature stores are really, really useful for managing our features, for sharing our features and enabling reuse across models. We then get to a model building stage, a lot of stuff that we want to be able to do here. One of the cool new things around this is really AutoML and trying to use algorithmic approaches to optimizing the hyperparameters that we can select. But then once we've got a model that we're happy with, we've tested it, we're comfortable, there's multiple ways that we might want to deploy that into the real world. So we have different deployment options: single, silent, A/B, multi-arm bandits being some of the common approaches. And then finally, we've got the model live. We're going to want to be able to monitor it and basically set up alerts for if we see anything wrong with how it's performing in the real world. So there's a lot of stuff that we really want to have in place when we're running machine learning solutions in a production setting. And there's a lot of change going on around these all the time as new approaches become available. So we're at a Python conference though. So I wanted to mention Python. So if we go to the next slide. Really, so not about 90% of the stuff I think we have is Python. We have bits of Java and C in places, Terraform for obvious reasons, but really the bulk of what we're working with at an engineering level is Python. I think, of course, if you're going to a lot of our favorite Python libraries, though, there's underlying C++, but Python is where the bulk of the teams are operating. So as with any sort of good engineering team, we have standards. So we have standards and best practices that teams are encouraged to use. These have the benefit of ensuring that the engineering that's going live is of a certain good enough quality. But also, by having some of these standards, it means it's much easier for teams to help one another or for people to move from one team to another, because actually they've got that baseline understanding of what code looks like. In addition to our standards, though, we've also got a number of small components that the teams are able to use and share. And so if you click again, Benny, what you'll start to see is that we've got lots and lots of different components that teams are able to reuse and reutilize. So, I mean, this is everything from having standard project templates, testing frameworks. A lot of our CI/CD stuff has been set up, so it's ready to roll onto that next project. And then there's bits of code that are effectively there to be reused as templates. So things like how we do our logging. What's important about this is effectively, as mentioned right at the start, we have a large organization, many data science projects, many data science things going on. By having these standards, by having these templates, it means that a new project comes along, a team is very quickly able to pick up these templates, these standards, and get up and running very efficiently, which is really key for us. So if we go back onto the final slide. So as mentioned previously, MLOps, this is where a lot of our work is going on at the moment. What are the emerging standards? What are the emerging approaches around this? And how can we do this better? We're continuously looking to improve on things. And Benny is now going to talk about search and recommendation, because that's one of the use cases that we've used to drive how we do feature stores. Just one final word from me, and that is, as we're building out all these new approaches and capabilities, it's always use case driven, and that's really important. So Benny, I'll let you take over now. Thank you very much.
Great. Yeah, so I'll give you a little bit of a flavor of one of the use cases here at Tesco, which is the search and recommendation space, and hopefully that will kind of integrate well with what Andrew's just presented to you. And so in the Tesco, if you're not familiar with Tesco, we're a big supermarket, but we also operate an online shopping website, the Tesco grocery home shopping website. And here we present the customer with a list of products in various different places. So, for example, there are recommendation carousels when you're on a product detail page that recommend products that you might want to buy next. That's the little screenshot here on the right-hand side. but also there's offers, offer carousels, or there's a search functionality where you type in a query and it will then return a set of products. And so the data science team that I work with essentially is responsible for ordering these products. That's all we do. We order products, basically. But we do that in lots of different and interesting ways. So as I've just described, there are multiple different use cases. And each of these use cases has its own statistical model that returns the correct ordering of products. But they're trained on similar input features. They're not always the same input features, but they overlap very much. So kind of to approach that challenge, the obvious solution is to use a feature store. Our feature store is built on Spark, but it's built on top of Spark. So when we say feature store, all it effectively is a set of tables in Spark. So it's a fancy word for collection of tables, if you will. And the kind of features in our feature store are either outputs of a data pipeline or a feature engineering pipeline, or they're outputs of the machine learning models themselves. So I've visualized a little bit here, that diagram. So you'd have your kind of basic data sources. So that would be sales data or your clickstream data, kind of raw data sources almost. And then we have a set of feature creation jobs, which will then populate our feature store tables. And then different combinations of these features are then extracted to train models that are specific to each use case. So we will extract those. We'll do a typical train test split, train a model, evaluate the model, save the model to a repository, and ultimately export to an API. And then separately, we'll also extract some of the features, send those same features to the API, or some of them at least, so that that data is available for us. And the API is just like models, the APIs are typically specific to each use case. Just to get into details a bit more, so this is one capability that we have developed over the last year or so. It is personalized search. So here, when you type in a query on in our search, you will get back results that are personalized to you based on your previous shopping behavior. And the way that we have split this problem up is quite typical for this space, and also for the way we generally approach problems in this area. So we have a candidate generation step where we reduce the number of products that we want to order. So we sell about 30,000 products, and here we use Elasticsearch, which is an open source search tool, which essentially does keyword matching to reduce that set down to just 72. And we have a feature enrichment step where we collect data for those 72 products. So those can be features specific to the product, such as the overall popularity of a product, or specific to the product. I've got 5 minutes.
Yeah.
I'll rush through it, and then we'll do questions in the Slack chat, I think, because we had some problems at the beginning.
Thank you.
So yeah, we have some product query features. So those are essentially the score that represents the keyword matching from Elastic. And then we've got some features that are specific to a user or the product user interaction. So that would be the user popularity. So how popular is a product for a specific user, but also some collaborative filtering scores. So those essentially identify similar users to the user in question to predict what that user might be interested in. Then we use a fairly simple neural network to predict whether a user adds a product to the basket. And that results in some scores. Those scores are simply ordered. And that's what we return at inference. And that results in the ordered personalized list. And that works quite well. So here are two examples. This is the unpersonalized results when you search for biscuits. And this is the personalized results for one of our colleagues. You can see that she or he has previously bought all the products that have these blue hearts, because those are part of their favorites list. And then our model also thinks that she or he might like Oreos, presumably because some similar users have bought Oreos before. That's it. I'll spend the last 2 minutes to acknowledge, well, first of all, Andrew's team and the engineers who help us do things. But I think in return, he wants to acknowledge all of the data scientists that work with the engineering team. It's a very great collaboration. I also want to acknowledge VertisLab, which is a company in Poland where the majority of our machine learning engineers work, and they are absolutely fantastic to work with. So big shout to them. Yeah. Last but not least, we're hiring always, really. So you can see there's a huge amount of different positions that are open. If you're interested in working with us, it's a fantastic team for the huge range of different problems, as Andrew said in the beginning. Get in touch. You can email us at datascience@tesco.com, or you can email our recruiter, Charlotte Krupe, or Andrew and me if you want. And with that, I will close.
Thank you very much for your presentation. Thank you, everybody who joined, and we're done. Thank you. Bye.